There will be one lab report per assignment. Submit your lab report to the teaching assistant per the person's instructions. This lecture is about how to prepare your lab report. The lab report for download is a template for you to work on. Its content is empty. By following the guides, you will create the content of your lab report. Not every single item of a lab report template is required. Some parts are skipped, or to be done only as an option, or for bonus and extra credits. Check the course announcement via email or posts on the course website about each lab assignment. For those who do the parts of a lab report for extra credits, surplused credits will be tallied near the end of the course, and it may exempt an individual the final exam. Or a final exam that doesn't need a high score. 2 file formats are accepted. Mathematica Notebook or PDF. Mathematica Notebook, like Jupyter Notebook for those who are familiar with Python, can be used as a plain text editor. A tutorial for those interested can be given. A Microsoft Word file, including all the hyperlinks to multimedia for example, should be converted to PDF. A time-honored, and romantically nostalgic format is of course, the handwritten notebook. It is a great exercise of the brain per the science of neuroplasticity to think and write. Many centuries later, who knows, a single sketch could fetch $12 million, and your notebook might be solved for hundreds of millions of today dollars, although by then, the value might be listed in cryptocurrency units. Regardless what format, one important thing is, whose book is it? Just like a notebook without name, the grader would not know who to be credited with the score. An electronically submitted file should also have a name on its cover. A bot may be used to scan the email and check for submission. Last name and first name on the file will be useful to record the submission. In the follow, discussion will use Mathematica Notebook for illustration, but the principle is applied to all formats. If Microsoft Word file is used for editing for example, each item title of the lab report template should be copied over. To open the cells of the lab report template, just double-click the cell brackets. For each task, simply type in the response it asks. For example, in this case, the question is whether the breadboard as distributed is ready to be used. An answer can be typed in, for example, it is false that the breadboard is ready to be used as is, because the binding posts for external power supplies must be installed. If you are in the lab, you can show the proctor your breadboard, or if you at home, you can follow the instruction of taking a picture and pasting it in. This case is also an opportunity to discuss about image format. The image resolution should be in the range of 500 to 800 pixels. Avoid extremes such as 3000 pixels, too big, or 100 pixels, virtually unviewable. Many software can do image resizing, including PowerPoint. If one wish to do it in Mathematica, a tutorial can be given. This is an example of resizing. More generally, what in a lab report can be put in 3 categories: text, graphics, and multimedia such as videos and sounds. For text, the criterion is basic clarity, readability, and sufficiency. Short, concise, to the point and informative are most desirable, no need for smooth or fancy proses. There are numerous writing assistant software that can help this. A picture is worth 1,000 words, graphics is a powerful instrument. However, there are things to be considered. First is the file size, which should not be more than needed to convey the relevant information. Look at this figure, it is reduced from 3400 pixel to 500. It still conveys what it is, a picture that shows a circuit that a student team built in 2018. Next, every graphics must have a caption, unless the caption is itself embedded in the graphics. An uninitiated reader generally will not understand what a graphics is about without some explanation. A learned circuit builder will recognize the figure on the left is a circuit. But what is that circuit? What does it do? A caption as shown allows an uninitiated reader to get a rough idea. Lastly and most importantly, graphics are used to illustrate or support some things, not as standalone entities. For example, it serves as an evidence that you built the circuit, or that your circuit is working the way it should. But sometimes, things can be more complicated. Consider a complicated graphics. It says it is an impulse response test. But what is the implication? What is the point to be made here? This is an example about how graphics should be used as evidence to support some point or some claim within a broader context, not as standalone entities. Consider this analogy. Imagine a lawyer who would put up a picture of some objects, saying, "Ladies and gentlemen of the jury, we hereby present the evidence." The end. The jury would not understand what is the point of that picture evidence. To present an argument, the lawyer must state what that evidence purportedly shows, such as, "This evidence shows that the defendant did, or did not commit such and such act." Likewise, the graphics in a lab report should be cited in the associated text what it is and what it means. For the scary-looking figure on the left, it is a time domain test of a LED photo receiver system. A 250 nanosecond pulse, the yellow spike, is sent to the system. But the best the system could do, as shown with the blue-red trace, was to gradually rise that took almost a microsecond, and even more slowly fall over several microseconds. This is like a homework is posted, to be due in 2.5 days. But the students take a week just to ramp up reading the homework, and take 3 more weeks to gradually finish the homework. The implication is that this LED photo receiver system, if used in applications such as communications, cannot send 2 successive bits sooner than about 4 microseconds apart, or a data rate more than 250 kilobits per second. Just like for this student system, it is futile to give homework more frequently than once every 4 weeks. Occasionally, a task in a lab report may specifically suggest a multimedia demonstration. It is generally an option at the student's discretion. A picture is worth 1,000 words, then a video is worth 30,000 words per second at a frame rate of 30 per second. The real question is it worth it? What does a media file offer more than text and a few graphics? Vast quantity of technical literatures in the past had no need for multimedia. The video on the left can be described in words, such as, "The circuit generates a tone at such and such frequency." A plot of the potentiometer resistance, the component with the knob being tuned, versus output frequency can be presented. However, it is undeniable that video and animation offers a communication capability beyond what static images can offer. A 50-second video enables one to grasp the matter in a more intuitive, visceral manner than words and static graphics, which would require vivid imagination on the reader. Hence, in this course, you are encouraged to record your work to archive your learning. However, multimedia demonstrations cited in a report should offer more substantial technical values to your report than simple graphics. A video of, for example, a circuit with constant LED light on, which can be replaced with a simple static picture, should be unnecessary. Use your discretion in using multimedia for the lab report. The discussion so far covers the mechanical aspects of the lab report. We now discuss something more important, the content. Lab work reporting is a general practice in almost every endeavor and activity involving experimentation, be that in school, academia, or industries. The follow will present considerations lab work reporting in the general sense, and how the lab report for this course should be in that bigger picture context. In industries, lab work, experimentation is a process to produce values, such as know-hows, trade secrets, or things generally categorized as intellectual properties. For a research and development scientist or engineer, his or her lab report represents the labor output, productivity. Any worthwhile lab report would be an item of archival. Sometimes, even a report of simple observations, in a military lab, it might suddenly be classified as secret, and even the one writing the lab report, if not having secret clearance, may no longer have the permission to retain the content of that report in one's mind. How to do that is a different matter. The bottom line, a lab report in general is meant to have intellectual values. In this course, the lab report is both an essential component of empirical learning, and an exercise to prepare the student for a professional career that may involve lab work reporting as a production of intellectual values. Unlike professional scientific journals, or documentation of intellectual properties like patents, there are no international standards for lab reports. That said, there are common sense features about the lab reporting practices. A difference between technical articles for publication and technical reports is that the latter need not be perfectly prepared and polished. The essence of a lab report is its content, not appearance. Yet, one fundamental criterion of a useful lab report is the same as that of scientific engineering or generally professional technical literature, which is technical sufficiency. It must have sufficient relevant information so that the work can be duplicated and verified by others. Although a lab report needs not be polished, it is still an item for communication. It is meant to be read, viewed by others, hence, it should meet the standards that allow someone to gain the information from the report in an efficient manner. Hence, a lab report may not need good writing or perfect graphics, but should be organized and comprehensible. Since a lab report is meant as a communication piece, it matters who are the intended audience. The most common audience are peers, people with similar backgrounds and comparable knowledge. In a teamwork environment with people of different backgrounds, it is also important that a lab report be not so arcane that co-workers and collaborators working on the same project, but not in the same field of expertise, can also understand its significance and the implications. If it involves intellectual property values, the technical report should also be sufficiently intelligible to legal professionals of intellectual properties. In fact, many high-tech companies want their workers start their technical lab reports with the end goal of a patent in mind. Hence, the writing, the presentation is almost like for a provisional patent. In this course, the lab report is meant for peers. It should be something that a person of comparable background and interest can understand what was done, why was it done, how was it done, and what is the implication. There are 3 segments in this course lab report. Segment 1 is for background, context. Parts of this segment are named like introduction, or part 0, part 1, numerals are used instead of letters. Segment 2 is, quote-unquote, the heavy thing. This involves circuit building, tests, measurements, and demonstrations. The parts are named with letters like A, B, C, D, etc. The last segment, last but not least, is where you will write a synopsis of the entire lab work. It is a summary, but should also contain discussion, your thoughts, your learning. Ask yourself, can your peers, parents, siblings, relatives, significant others understand what you have done? Write in a manner that the general public can relate. Something that you would not mind to post in your social media. When you put yourself in others' shoes, you will see that, like a mirror, you can see a lot of things about your work that you might not realize before. Hence, although only 1 or 2 pages are recommended for this segment, it is worthwhile to put an honest effort into it, but needs not be excessive, because, after all, rough unpolished lab reports are fine. The follow shows a few pitfalls that a lab report should avoid. They are mostly common sense. The last line is very important. Remember this: it is like in a talent show, your lab report is like your performance to the big audience. The talent evaluators will see how the audience react to your performance. Likewise, the instructor and teaching assistant are the graders, putting themselves in the shoes of your true audience. Hence, they should be the last people in your mind when writing the report. If you think that your classmates, peers will be impressed with what you write, so will the graders, and the report will get an evaluation it deserves, like an ovation from the audience of the talent show. This is to put all the points above in a more vernacular expression.